Your favorite algebra teacher. I know, I'm your only algebra teacher, but we're going to go with it anyway. Today we're going to talk about solving another kind of equation, an absolute value equation. So you're going to notice the picture here shows kind of a distance from zero. So you see this point is 3 units from zero going in the positive direction, and this point over here is 3 going in the negative direction, and boy, are we going to be kind of talking about that a lot. So before we start, let's just remember absolute value. It's the bars that look like the goalposts, right, on the football post at the end. And we've talked about that whatever comes out of the absolute value, right, is always positive. So my question is, the absolute value of what number equals 7? Or should I say what numbers? So that's the first thing I want you to think about for a second. What can x equal? Did you say 2 solutions? Because the absolute value of -7 is 7 and the absolute value of +7 is 7. So there are actually 2 solutions there. So notice when the absolute value equals that positive, there are 2 possible answers, right? So going 7 units to the left to the negative direction of 0 and 7 units to the right or the positive direction of 0. Now what happens if the absolute value of x equals 0? What's the solution there? What is the value or values that x can take on now? Did you say there's only one? Because 0 isn't positive or negative, x can only be 0 for the absolute value of 0 to equal 0. And one more here. The absolute value of some number equals -9. What can x be now? Careful on this one. Remember that absolute value is always what? What word? Positive. So right here, there is no value that x can take on that would give you the absolute value, turning it into a negative number. And thus, for those of you that do come into class, and for those folks that don't, I have an absolute value machine hanging over my door because I want everybody that comes in to always be positive. So there are 3 possible things that can happen. I want you to keep that in mind as we go forward. So again, the absolute value of a number is the distance of that number from 0. So if we were talking about something having the absolute value of 4, there are 2 numbers that could do that. The absolute value of -4 and the absolute value of +4 would be 4 distance, a distance of 4 from 0. And when we talk about distance, it's always positive. We don't back up our car and have mileage taken off the odometer, right? So distance is always considered to be a positive value. So we're going to start with the most ridiculous, simple, easy equation, which we already did one a second ago. You know what number, so this is asking what number or numbers is 3 units from 0. That's basically what this is asking for. And again, if we look at the number line, it would be 3 and -3. So the absolute value of -3 is 3, and the absolute value of +3 is 3. So now we're going to up the game a little bit. And you're going to notice outside the absolute value, we have a +2. So when we have an equation that looks like this with absolute value, the first thing you want to do is isolate that absolute value. So in other words, let's do our opposite operations to move this 2 to the other side. So we're going to subtract 2 from both sides. And when we do that, we have the absolute value of x equals 2, and this looks like the one we just did. So we are thinking, if we go to the number line, the number 2 is 2 units from 0, the number -2 is 2 units from 0. And if we were to go back up here, we actually have to check both answers. So notice that these absolute value equations are kind of the first time that we're seeing more than one answer possible in an equation. So if I put the +2 in, the absolute value of 2 is 2, add 2 is 4. And if I put the -2 back in to the original equation, the absolute value of -2 is 2, plus 2 is 4. So you do, since you get 2 solutions, you do have to check both of them. I'm just waiting here a second. I talked this through. I'm just making sure everybody understands what I mean. But I put the 2 in for x, and I put the -2 into the original, and I checked them. Okay, so let's get a little bit more interesting here. And before we do, we have to have a little bit of music. So I'm hopefully that I significantly earwormed you there, and now you're going to be humming and or singing MC Hammer all day. But I did that on purpose. You see this -5, it is not outside the absolute values. It's inside, and that's a difference. I want you to think of these absolute value bars like a brick wall, and you can't just now add 5 outside the wall. Okay, so that's thus the MC Hammer. You can't move terms from inside the absolute value signs. So let's talk about how to solve this third absolute value equation. So basically, once you have the absolute value isolated, no matter what's inside, you take what is inside and ask what number -5 will be 3 units and what number -5 will be -3, talking 3 units in either direction from 0. So basically, once you've isolated the absolute value, take what's inside, x -5, and set it to the negative of this value. Take what's inside and set it equal to the positive. And what you have here are 2 equations. One-step equations. Now, because there are no longer absolute value bars, you broke those down when you wrote these 2 equations. They kind of go along with the number line. Once you've written these 2 equations, what's inside equal to the negative, what's inside equal to the positive, you're just going to solve these now by adding 5. -3 plus 5 is 2. And adding 5, and notice we have 8. Now, the first thing I want to draw your attention to is realize that here's an example. We don't have a solution like 2 and -2 or 8 and -8. When we have a plus or minus inside the absolute value bars, our answers will not be symmetric around 0. Because that's the first thing. The second thing was, but Mrs. Woodruff, I was going to add 5 up here. And if you did, you would have gotten the x equals 8 answer, but you never would have gotten the second answer. So when you have absolute value equal to that positive number, you take what's inside equal to the negative, what's inside equal to the positive, solve those. Now these 2 solutions, I am going to put back in the original. And here's where I'm doing that. So 2 minus 5 is -3, but when I take the absolute value, that's 3. And 8 minus 5 is +3, and when I take the absolute value, it's 3, and I've checked my solutions. So let's take a look at another one that's far more interesting here. So notice that the -2 and the multiplying by 3 are on the outside of the absolute value bar. So we can solve using our opposite operations right now. So, imagine that this is 3 times, let's just call this like y. 3y minus 2 equals 7. You would start by adding 2 to both sides. And that's what I'm doing. So I'm just kind of letting this unit travel down with me, okay? So I'm going to add 2 to both sides. So I have 3 times this now equals 9. And now that 3 is on the outside, so I can divide both sides by 3. And now I have isolated my absolute value. Now it is by itself, no operations of math being done on the outside. So again, remember on the number line that you're talking about this being 3 distance in the positive and this being 3 distance in the negative. So what I want you to do right now is just pause the video, and what would the 2 equations be that you would write to get rid of those absolute value bars? Okay, let's see how you did. Did you take what was inside and set it equal to the -3? And that would be this situation right here. And did you take what was inside and set it equal to the +3? And that's what would be happening right here. Do you need to do this number line? The absolute answer is no. But I'm just trying to give the folks that need a visual that information that might help them understand what's going on. So basically, once you've isolated the absolute value, there's no math happening on the outside. You take away the walls and you set what is inside the absolute value equal to the negative, and you set what is inside equal to the positive. And now you've got, what, 1-step equation? So you're going to subtract 1 here, and get x equals -4. And you're going to subtract 1 here and get x equals 2. So your two solutions that should work in that original are -4 and 2. That -4 needs to go back in the original. I mean, it's really tempting. I want to just check it right here. It's so easy. But if you made a mistake getting there, you will not catch it. You always check in the original up here. So I'm going to put that -4 in. And on the other side, I'm going to put the 2 in. Okay, so, can you do the math, and are you comfortable doing that moving forward? Remember that the absolute value bars are like a grouping symbol. So you do what's inside first, like the P in parentheses. So you would have 3 times, I can't get my finger on the right part of the mouse today, 3 times the absolute value of -3 minus 2 equals 7. Now take the absolute value of -3, which would be 3, and 3 times 3 is 9. Subtract, and I'm happy over here. Now, 2 plus 1 is going to put a 3 inside the absolute value. The absolute value of 3 is 3, so I've got a 9 minus 2 again, and I'm happy again. So that's how we solve an absolute value equation. So take a look at this one. What if I had the absolute value of 1/2 x minus 13 equals -19? You can think about the number line. Pause the video and see if you can come up with what you think the solution is here. Okay, did you catch it? Absolute value is isolated. Can it ever be equal to a negative? And the answer is no. Can't have a distance from 0 to be negative. You don't have to show any work here. You can just say what? What do you think it is? No solution. The absolute value can't be negative. You can't check it. You move on. You're a happy guy or a happy girl. Okay, here's another one. Absolute value equation 6. I have it isolated. It equals 0. Think about the number line. What do you think the solution? Solutions, no solution. What's going on here? Did you get it? 0 can't be positive or negative. So there can only be one solution here. There's only one equation because I'm not going to take what's inside equal to the -0 and what's inside equal to a +0. You're only going to have one equation this time when it equals 0. So I solve what's inside equaling 0, and the only possible solution would be -1. So basically what we found is there's sort of 3 things that can happen. We started with that. We started talking about that at the very beginning, that there were 3 possible things that could happen. To figure out what's going on, the first thing you're going to do is make sure the absolute value is isolated on one side of the equation. So do the math of everything surrounding the absolute value. Then, once you've done that, you're going to make 2 equations usually. Think the number line. You're going to take what's inside the absolute value and set it equal to the positive. You're going to take what's inside and set it equal to the negative. And then you're going to solve those equations. Now, if you end up with the absolute value equaling a negative number, you're done, no solution. If you end up with the absolute value equaling 0, there will only be one solution. You take what's inside equal to 0 and solve it. So at some point in time, really soon, like in Unit 3, we will see a picture of an absolute value equation. We'll see the graph, and all of a sudden, these 3 possibilities of 2 solutions, 1 solution, and no solutions will show up, and it will be a lot clearer. But today, we just need to do the algebra. I hope that the start of absolute value equations is making sense. It's time to practice. So guys, have a great day.